notes out, we'll just discuss this, and then this can be a bit of weekend homework for fun. So 3A, we know what composite functions are, but we are asked specifically in our notebook here to state the domain and range of composite functions. So this is going to require us to think a bit. Of course, we can use our calculator to support us. So the first one says, find f of g of x and state its domain and range. F of g of x. So we're putting g of x where the x is. All right, that's going to be the square root of 2x take 3. All right, let's come up with an argument for its domain and for its range. Firstly, for a function, okay, for a function, it has to have a positive number in here. All right, for it to exist on the Cartesian plane, this needs to be positive or equal to 0, because you can have the square root of 0. So therefore, 2x take 3 has to be greater than or equal to 0. All right, and we'll just go through and solve this inequality. Okay, so the domain, it exists for values of x that are greater than or equal to 3 or 2. And then you always notice, whenever you graph a root function, right, it only considers the positive values, okay? And the answer is because it's a function, okay? So because it's a function, that means it has to pass the vertical line test, which means each x value has one unique y value. So all root functions are going to look like that, apart from if there's some vertical or some vertical translation, shift it up or down. So that means for our range, y is greater than or equal to 0. All right, and you can think about this. If I put 0 there, we have the square root of 0, the y value will be 0. If I put 1 in there, you're going to have this square root, x has to be greater than 3 or 2. So if you make that 0, it's going to be the square root of 0, which is 0. Anyway, this one, horizontal translation 3 and 2, starting. That's what this one looks like. Okay, let's move on to the next one. G of f of x. So now we're putting the root there. We've got g of f of x. It's going to be 2 root x take 3. Now that take 3 is sitting outside. So we can think of it like it's a root function and then it's moved down 3 units. It's been shifted down. That's the vertical translation. So when we do the domain, we're just going to have x has to be greater than or equal to 0. All right, that number in there just has to be 0 or larger. And then for y, for range, the range is going to be greater than or equal to -3. The reason is because it's been shifted down 3 units. Okay, C requires a bit of thinking. We've got p of x is cos x, and it says find f of p of x. So that's going to be the square root of cos x. And state its domain and range. So a cos x function is a periodic function. So that means it goes on forever, but it also fluctuates. It has positive and negative values. So let's think about the graph of cos of x first. I'm going to start at 0 here for the cos of x function. It goes like this, doesn't it? It goes down and then up and then down and then up. It keeps going. And so what that means, if we're going to square root it, if we're going to have the square root of it, it's not going to exist when it's negative. So it's not going to exist there, it's not going to exist here. Right? It's only going to exist when it's positive. So let's transform from the graph to a sign diagram, because that's going to be easier for us to understand it. So if I'm going to draw the sign diagram, here's 0, here's pi on 2, and here is negative pi on 2. And then it's 3 pi on 2. Okay? So if we just think about the graph of it, or even going around the unit circle, okay, if we go from 0 to pi on 2, we have positive values of x, and then between pi on 2 and 3 pi on 2, we have negative values of x. Okay, think about your unit circle, here it is, we've got positive values of x from pi on 2, and then here we've got negative values. And so when it's negative, we're not going to have a solution. Okay, so anyway, what we can see is that it's positive between minus pi on 2 and pi on 2, and then it's going to be positive between 3 pi on 2 and 5 pi on 2, and 7 pi on 2 and 9 pi on 2. Okay, it's going to continue that trend. So we're going to have the domain is pi on 2 is less than or equal to x, which is less than or equal to pi on 2, so negative pi on 2, true pi on 2, plus k pi, where k is equal. No, k2 pi. Plus k2 pi. Should write it here, sorry. k2 pi. Where k is equal. That's better. Okay, that's our domain. Alright, so it's going to be positive, it's going to exist. If we think about the square root of cos x, it only exists when cos x is positive. Cos x is only positive at these intervals. Okay, so that means that's our domain. For our range, how about our range? Well, the range is the square root of the cos value. And we are only considering positive values of the cos function, aren't we? We're only considering the positive values of it. And so the lowest positive value of cos is 0, and the highest possible value of cos is 1, and the square root of the highest possible value is 1. So our range is from 0 to 1. Okay? If you can't think about it, graph it, you'll see the same observation. You can notice the pattern and you'll be able to make that statement. Okay, and then the last one we have is q of g of x. So this is for d, q of g of x, which is 1 on 2x take 3. Okay, so we should recognise straight away that this is going to be undefined when the denominator equals 0. Undefined when the denominator equals 0. So that gives us x is 3 on 2. That's where it doesn't exist, which means the domain, it exists for all values except that one. So the domain is going to be x does not equal 3 on 2. So we've got when it's undefined, and so therefore that's our domain. It's not equal to that value. When we think about range, okay, if you were to look at the graph of this, alright, what you would see, it's going to look, I'm just going to do a very rough sketch, it's going to be something like this. Where this is 3 on 2, so yep, that's okay there, and then we'll have it here. Alright? But the point of this is to show you is that there's actually a horizontal asymptote as well. Alright? And that is 0. It doesn't equal 0. Why? Well, what values of x are going to make this equal 0? None, because the numerator will never equal 0. Alright? So we can see that from the graph, and we can even see it from thinking about it if we're familiar with these types of functions. So the range y is not equal to 0. It exists for all other values except 0. So that's enough to get started on 3A. Use your calculators to support you. Let's do it.